Now we're back to look at some other places where energy is used on a daily basis. And I have two young scientists to help me out. I have Jamie and Rachel. And you two had questions when we came to film at your school. And I just want to remember what your questions are. And we're going to do some experiments where we answer them. Jamie, what was your question?
My question was, how do batteries store energy?
Excellent. And Rachel?
My question was, could we ever turn lightning into energy we could use in cars or other form of transportation?
Ooh, and we're going to answer both of those questions, actually. But we're going to start with yours, Jamie. And batteries, how do batteries store energy? And what we're going to do is we have a little bit of an experiment right here. And there's a clock. And if we look in the back of the clock, we've taken out the battery. And instead, what I've done is I've clicked on these wires. What I'm going to do is put on pieces of metal. And this one is a nail, which is coated with zinc. And this one is a penny. Do you know what pennies are made out of?
Iron.
Copper.
Copper.
Copper. Pennies are made out of copper. So I'm going to hold this nail in my hand right like this. And I'm going to hold a penny in my other hand. Rachel, you're going to hold this nail in your hand. Then you're going to hold the penny in this hand. Rachel, you're going to hold that nail. And then you're going to hold this penny right here in your other hand. And when I hold on to the nail, watch the clock.
Whoa.
And the clock is running. Now, we are the battery right now. You two, plus me, plus the pennies and the nails makes the batteries. And that was your question, was how can you charge up, how do you make a battery? Well, batteries have energy in them. Where is the energy?
In us?
In you and
Penny,
the penny and the nail. Yeah. We all have what we call chemical energy in us. What's happening is there's chemical reactions at the penny and the nail that produces a small voltage. But it's enough with three of us and three pennies and three nails that we can actually make this alarm clock run. So the key point here is that energy is hidden in common items that we use every day. It takes energy to grow and transport food. It takes energy to make the packaging that food comes in. And it turns out that much of the cost of the packaging, much of the cost of food, is really the cost of the energy to make it or to grow it.